Hey guys, so today we're gonna talk about the combined gas law. There's a couple picture of my daughters there, just to you know start off this presentation. So the combined gas law is used to predict the effects on the different properties of gases that we discussed when we're changing some of them. It can be one or a bunch. So we're going to compare the initial conditions to our final conditions. So the combined gas law is the P1 V1 over N1 T1 equals P2 V2 over N2 T2, where the P stands for pressure, V is volume, N is moles, and T is temperature Kelvin. The ones are the initial or starting conditions, and the twos are the final or end conditions. And when a variable is not mentioned, we assume it to be constant and remove it from the equation. A lot of times a problem will specify that one or more of the variables is constant. So to quick recap, I am part of the PVU table, which you guys have as a reference. If you guys are confused by the numbers and letters and stuff, take a look at this. The units are used to describe the properties, and the variables are letters that we use in equations. So you guys can reference this if you don't know what a unit meant, what property a unit is describing. So, use that as a reference. It's available to you. And also the temperature must be in Kelvin. We can't use temperature Celsius because temperature Celsius is not absolute, where temperature Kelvin is. It has an absolute zero and is directly related to kinetic energy. All of the gas laws are in the combined gas law. So we assume constant. So at constant moles and temperature, I have P1 V1 equals P2 V2, which is known as Boyle's law. At constant pressure in moles, I have V1 over T1 equals V2 over T2, which is known as Charles' law. At constant volume in moles, I have P1 over T1 equals P2 over T2, and that is Gay-Lussac's law. At constant pressure and temperature, I have V1 over N1 equals V2 over N2, and that is Avogadro's law. And at constant moles, I have P1 V1 over T1 equals P2 V2 over T2, which is the normal form of the combined gas law. Another thing, so the steps for combined gas law problems, what you guys are going to do is you guys are going to identify all the variables given, set up the combined gas law equation, cross out the variables that are constant or not mentioned, because we'll assume they're constant if they say they're not changing, and then solve for the variable in question. You can use algebra or cross multiply. And one more thing, if it's ever an STP condition, like say, what is the volume at STP? That means standard temperature pressure. That means your standard temperature, or T2, will be 273 Kelvin, or your standard pressure will be one of these values: 1 atmosphere, 101.3 kPa, or 760 millimeters of mercury. So here's an example of a gas law problem. A sample of a gas occupies 200 milliliters at 150 Kelvin at 1.5 atmospheres. What is the pressure if the volume is decreased to 100.0 milliliters and the temperature is increased to 300 Kelvin? So let's go about how we'd solve this. First off, I would set up a chart with all my variables. And then I would go through the problem and identify what's given. So my initial pressure is 1.5 atmospheres. My initial volume is 200 milliliters. My initial temperature is 150 Kelvin. I'm asking what is the pressure. So I want to find the final pressure, P2. That's why I put a red question mark there. At a volume of changing to 100.0 milliliters and a temperature changing to 300 Kelvin. Now you might notice I don't mention moles at all, so I'm going to assume that's constant, and I'm gonna cross that out of the equation. So I have all my variables listed here, and I'm gonna go through solving this. First, I'm gonna write my ideal gas law. I'm going to cross out moles because they're not mentioned in the problem. I'm assuming they're constant. So N1 would equal N2. So I don't need to include that in the equation. So I substitute for my variables and all my numbers. So I have 1.5 atmospheres times 200 milliliters over 150 Kelvin is equal to P2 times 100 milliliters over 300 Kelvin. I can use algebra. I can cross multiply. I like to multiply by 300 over 100, both sides, and I would get P2. Notice also my units cancel out here, and I'm left with a unit of pressure. So that should always be the case. And I solve for my variable P2, and I get 6 atmospheres. So I'll do a couple other versions of this, guys, and a couple styles of problems. And we'll continue with this next class. Bye, guys.